Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
In this situation, we're considering a spider that's hanging from a thread, and the spider has a mass m sub s, and the thread has a Young's modulus y sub t. The radius of the thread is r, and the mass of we want to consider now a person who's hanging from aluminum, and it wants to know what radius of the aluminum wire would need to exist in order for it to exhibit the same strain as the spider's thread. Okay, so to do this, we're going to use the equation that says force is equal to the Young's modulus times delta L over L naught. The ratio, delta L to L naught, is the strain that we're wanting to find, multiplied by the area. But the area here is pi times r squared. Okay, so what we want to do is we want to solve, in this case, for delta L over L naught. So delta L over L naught for the spider is going to be equal to the force from the spider, which is going to be m sub s times gravity, divided by the Young's modulus for the spider's thread, y sub t, times the area of the spider's thread, which we called pi r squared. Okay, for the human, we're going to consider the same stress, or the same strain amount. So delta L over L naught is going to be the exact same for the human. And the equation is going to be the same, but we need to replace it by the mass of the human, the Young's modulus for aluminum, and the new radius that we're trying to calculate. So what we have here is we have the mass of the person, m sub p, times gravity, divided by y sub a, because it's aluminum, times pi r, and we'll call this one r prime. This is the new radius squared, is equal to, we have mass of the spider times gravity divided by y sub t times pi r squared. Some things will cancel here just to simplify a little bit. The gravity is the same for both, so g is going to cancel, and pi is the same in both situations, so pi is going to cancel. We can solve for r, and we find that, we can solve for r prime, and we find that r prime is equal to the square root of, the first thing we have is the ratio of m sub p over m sub s, right? Then you have the ratio y sub t over y sub a, and then you have it also multiplied by the ratio of, then you have it also multiplied by r squared. So plugging all those values into this expression, we find that r prime, or the radius of the aluminum, is going to be equal to it's going to be equal to 1.0 times 10 to the minus 3 meters. We can box this in as the solution to our question.